Okay, for example 2, we want to find the inverse function. Okay, we've done this before, but this is a different type of function. This is an exponential, and example 3 is a logarithmic function. If you recall, when we're trying to make the inverse of a function, xy is better than f of x and x. So where this function is listed like this, I'm going to write it as y equals 10 to the x plus 1 power. We create an inverse function. Anytime you want to create an inverse function, no matter what you're dealing with, you're going to swap the x and y coordinates. That's how you make an inverse function. Every x becomes y, every y becomes x. Everything else in the problem stays exactly where it is. So equals stays equals, 10 stays 10, plus 1 stays plus 1. Y becomes x, x becomes y. That's how you create an inverse function. Now, my task is to get y equals, and currently y lives up in the power level of this problem. So what I'm going to do is I'm going to rewrite it as a logarithm. And if I write this as a logarithm, it's going to be log of x base what? Base 10 equals what? Y plus 1. Just simple change from exponential to logarithmic form. Whatever the exponential expression equals, that's what log we're taking. Log of x. The base of the exponential is the base of the logarithm. The power of the exponential is the answer to the logarithm. Just change it from exponential to logarithmic form. And notice it says y plus 1 equals that. I want to get y equals, so I'm going to move the 1 to the other side. I'm going to get log of x minus 1 equals y. Now notice I didn't write base 10. I want you to get accustomed to that. Base 10 is an understood base. Base E is an understood base. You write ln for that. If you get accustomed to those two bases, because those are the most commonly used bases here, it won't freak you out when you don't see a base written. You see log with no base, you know it's base 10. You see ln, that's base E. Otherwise, the base has to be written. If this said f of x equals 5 to the x plus 1, base 5 would have to be there. You'd have to have it written in there. The other thing you'll notice here, it's only log of x. We're subtracting 1 from the logarithm. So notice I put parentheses around the x to make sure that the reader doesn't think that x minus 1 happens, then you take the logarithm. It's log of x first, and then minus 1 second. And the final thing I'm going to do is write good inverse notation form. I'm going to have f minus 1 of x equals log of x minus 1. Rewrite y as our inverse function notation. I'll go ahead and tell you exponentials and logarithmics are both functions every single time. So you don't have to do any testing or anything. If you have an exponential function, you make its inverse, it'll be a function. If you do logarithmic, its inverse will be a function. So no testing necessary on those. You can just immediately assume functionality.